Hey guys, so I came back to this scene. I just wanted to polish it up. I didn't feel like it was quite tight enough at the end of the last session. So I came back into this nab cube rotation effect. And I went back into Ian Waters' video and I noticed a couple of very specific things that I hadn't done. The first thing that I didn't do is I didn't keyframe starting at the origin. So the object that I have as the parent to translate, I'm going to start at the origin and then come off to the side after everything is rotated and then key it there at frame 55. So let me go back off like that and key it. And then this last key that I just made, let's put that one back at frame 1. So now when we play it back, it rotates and turns over and settles like so. Okay, and then I also increased the size a bit so that we could see the effect a little bit more clearly. So I did a 15 by 15 with a 16 by 16, but you could just as well have a 15 by 15 and you would have just a small little gap in between them, which could be good for maybe catching a shadow later on. And then we can, increase the size of our ground catching the shadow. Another thing I added as an option was a third offset node at the bottom. And this is simply to set, do we start with the green side or the red side first? So if I enter 0, I'm on the green side, the flat side, and if I'm at 180, I'm on the red side. That was just an option. I wanted to throw it out there that you could switch which side you're starting on by adding another offset node there. Then the translation offset, which is position only, moving up a unit, that offset node I have set to add. I have the inner zone set to 0.5 and I have the fade set to 0.019. I think it's a little slow, maybe 0.025 or maybe even 0.03 would be better. That might settle a little quicker and get into position. And then I have the spring turned off, but if I turn the spring back on, go forward, and there's the little wave there. And then as for the inner zone, outer zone, right around here, that little hump, that's going to be in here, and that's going to be really the inner zone and outer zone. So we can tighten that up just a little bit more by increasing the inner zone. And the same thing on the rotation. The rotation has an inner zone. We can tighten it up. Okay, endless play really. And I'm just going to continue tweaking this until I'm happy with it. Oh yeah, one other thing. I also disabled rotating on both the X and the Z. That had a really weird result. I'm sure you caught that. So just rotate on the X or the Z. And in this case, I even inverted rotating on the X-axis because I thought that the rotation had a better feel as it came across. And you can see the difference if I enter 180 and play. It's really in the direction that they're rotating. So we can see it's almost like they're getting pushed in this version, whereas in this way backwards, it's almost like they're being scooped. It's a little different. And I think it has a lot to do with the angle at which I'm approaching it. Again, subtle differences, but fun. Okay, and then I see one more thing that I need to edit is that my offsets are not matching, and it has to do with the scale of the child. So I need to set the scale of the child to 111 And now the rotation is matching. I thought something was a little off there. I couldn't quite see what it was, but now the rotation is matching that wave. Okay, so when I made this second offset a child, I needed, and that scale was 22 something. I actually have some strange scale of 22 now. That child needs to have the same scale. So in order for it to have the same scale, set its scale to 111. Yeah, and then finally I noticed that I had mode add turned on for the translation, and I had some add mode fade on it, and it tends to like stay up in the air too much, so I just want it to pop up and come down. And so normal, it goes up and it comes back down, and now we see the wave of the spring much more clearly, and that's much more simple, and that's in line with what Ian Waters did. Okay, I feel like this is a good close of this one. I'm going to go on to the next MASH example. Okay, in this next one, we're going to merge MASH networks. And this was a really big one in the Aquablock work that I did a year ago, a little over a year ago. And you can see an example of merging MASH networks on Ian Waters' channel. And I'm going to basically do something similar to this. And I hope to take it just a little bit further, where I transition from pulling something off the ground, forming it into something, and then sending it back down to the ground. So here's how we do it. First, you're going to need the polycube, and then you're going to create a MASH network from it. And this MASH network we're going to call the pile. And in this one, we'll generate a grid, and we're going to generate a 10 by 10 by 10, 10 by 10 by 10. That should give us 1,000 points. And then with this grid, we're going to run dynamics on it and drop it to the ground. So in order for us to drop this to the ground, we're going to use a collision shape of box, and we're going to give it some friction, some rolling friction, some dampening, and some rolling dampening. And that's about it. And then we're going to rewind, set this to about 1,000 frames, and hit play, and let it play through, falling to the ground. And go ahead and let it play out for a little bit till it starts to come to a stopping point. And once you feel that it's a good stopping point, probably about 400 or 500 frames, it starts to come to a stop. Then we can stop it. Okay, then from here, we're going to go into our dynamics underneath sleeping initial state and hit this plus icon. And now it says MASH dynamics initial state. And what we've done is we've established that this is a pile of junk, and we're going to pull that pile of junk up into the air and form it into something. It doesn't display the MASH dynamics initial state, so I'm going to tear this editor off, close it, and then reopen the editor, and you can see the dynamics initial state is there. Disable the dynamics so that this dynamics initial state basically preserves the positions of the points where they are, the positions of the cubes of where they are. Okay, next we're going to get another polycube, create cube, and this one's going to be up in the air. So again, create MASH network, and this one's going to be in the air, in air. And for this one, we're going to have an object to shape into. So we're going to get the torus. Go ahead and make this torus larger. It is okay to scale the object in this case. And then move the object away. And it's something like that. So we're going to find where this is and mash with it. So here under distribute, we're going to change distribution to mesh. It's going to be a scatter, and we want 1,000 pieces, and then the input mesh is the torus. And so now we've got 1,000 cubes on the surface of the mesh, and we are going to use face area. Okay, now I've got it in the air. There's an option under distribution to use the face area, and that simply redistributes them a little bit differently. Now I'm going to use a merge node to pull the objects up off the ground. And notice that I made an effort to make sure that my waders have the same point count. So I've got 1,000 and 1,000. So that way I don't have any stray points or stray objects unaccounted for. Then I can do this one of two ways. I can add the merge to the mash in air, or I can add the merge to the mash pile. Either one will work. We're going to do the mash in air version first. So let's go with the merge node. And the merge node requires a child node to blend into. So we're going to blend into the pile. Notice we do have an option to merge visibility. So if the visibility of certain nodes are turned on or turned off, it'll blend that as well. So you have an option to merge visibility. Then to really see the effect, you need a Falloff object. So we're going to right click in there and choose create. And notice all the objects disappear on the torus. So as we move the torus, as we move the Falloff object closer to the torus, we see the pile forming wherever they are related. The IDs are related in the torus. So what's really happened is that the Repo mesh is still sitting there from the first wader. We can hide it. So what's really happened is that the points on the torus were sent to the exact same location as the points in the pile. And all we're doing is we're pulling the points back up from that new position in the pile and pulling them up to the position of the torus, making it appear to be a blend. So again, we can scale this Falloff and even change the inner zone of that Falloff to capture more of them. I even went so far as to group. If you just make an empty group, deselect something and press Control G, and you can select the torus as a driver, select that null. We can call this like the merge center, and we select the torus and select the merge second, and go to constraint point, and then uncheck maintain offset, and that locator jumps to that location. And then we can take the Falloff object and make it a child. So now the child, the Falloff object has a center. So now we can key to that 0 position. So we can, and we have very well. I guess we could do a parent constraint really instead of parenting. Let me Shift P, and if I had another locator at the origin, again deselect everything, press Control G. This one's at the origin, or maybe at the center of the pile, which would be on the ground, -20. We could do a parent constraint between those two pieces, right? So we could do that's a driver, and that's what's driven, or driver, driven. So this is the pile position, and we take those two pieces and we do a constrained parent, and we could do a not a maintain offset, but apply that. We then have in the channel box, if you recall, in our constraint, we now have an ability to blend from one position to the next. So now we can just blend between those two positions, picking it up. Pretty cool. And we could key those values to create that effect. That's where if we really want to tighten it up. Then I wanted to go a little further and say send them back to the ground into a new shape. So let's make a new shape on the ground to send them back to. And we'll try to keep them at the same point count, but ultimately it more than likely won't matter. We'll take the same original cube and build a new network from it. And we'll name this one formed on ground, for the lack of a better name. And this will be a grid again, and we'll do a 25 by 25, and we'll distribute them 25, a distribution amount 25 by 25. And we really could do, whatever we want it to be. We could do that, and I suppose we could even hit 50 and get the exact amount, right? Because then our waiter will have the exact amount. And then we can always give it a transform node, as we've done before, and create a transform node from there, and then like reposition it, change its shape, whatever we want to do. This could be the foundation to a building. That's what I did with the aqua block. And now I want to send the stuff that's been pulled up into the air to that one. So again, you would think that we take the merge node. Let's try it out. We take the merge node and then we say, oh, in the last merge node we pulled the pile, but it actually pulled something like bullet solver shape, which is kind of interesting. I ran into this bug when I was pulling things from dynamic piling. So if I pull from in the air to this new merge, if I middle click drag and drop that as the child node, at first it seems to connect just fine, and then I create a connection here with the, I create a new Falloff object, and then as I pull it towards this position, we can see that it seems to connect pretty good. So every once in a while I run into an issue where the bullet solver shape gets pulled into this merge network. So if for some reason you're having an error that didn't happen to me this time, if you're having an error, check this child node to make sure it's actually not the same name. It should actually be the name of the previous one. So this is the mash pile. For some reason it pulled the bullet solver shape, and then this is the merged the mash in air child, pulling it to this next shape. Okay, so then it didn't happen to me this time. If it happens to you, let me know in the Q&A. I'm going to change this to a cube shape, and we can make it bigger, or we can change its scale. I'm not quite sure if this is a bug, why I can't change the shape of the Falloff node, or if I'm missing something, but the Falloff node, I should be able to change its shape. For some reason I can't change its shape in the viewport, but you can see if I select it here in the attribute editor, I can change its shape like so. And then we can basically send the cubes to this new position. All right. And let's rotate it. And we'll just make it a little bit bigger just to exaggerate the whole thing. All right, so that's in its new position, and we could even switch to object space and animate in that direction. And again, we can hide the mash in air, hide it, because what we're really doing is we're visualizing that one, and we're visualizing that same pile. If we go to the channel box, see, it's the same pile. All right, so that's a lot of things strung together, and if that didn't make sense, rewind and see it again, how it is I went from pile on the ground to the torus to the other formed object, and how I was able to hide the repro mesh as I went through. All right, so that finishes mesh number 3. Let's save it. And we can always work on making that look really cool and refining it as we go. But I want to get on to the next one and show you how the next one works. And if you want to try out the one that Ian Waters did, feel free to watch his video and make the one that he did. It's basically transitioning from one position to the next. I really wanted you guys to see the Aquablock version that I had done, which let me remind you of that, of what that looks like. Right, so here it is on ArtStation. So what I did is I took the pile from the ground, I pulled it up into the air, that's the air position, and then I drop it down into the structure. So the way I really made it is I made the building first, and then I made a pile, and then I pulled the pile into the air, and that pile in the air and the pile on the ground had exactly the same amount as the building and structure had. So the structure was made first, then I made a dynamic pile for the refuse, then I pulled the refuse in the air and sent it down to form into the structure. And the same thing with the foundation. Okay, and that's how I was able to string together 3 mesh networks, merging from one and then to another. Okay, so next one, mesh number 4. This is in our voxels and dynamics section. So we're going to start by creating a voxel and like exploding the positions in a sense. It's not really an explosion, but you'll see what I mean when we get there. It's more like bubbling out. But it's going to act a little bit like what I'm doing right here. And if we change some of these settings, and if I change this, so in a sense we're like blowing out these positions. Let's do this, do this, do this, and I'll show you how this is all made. In a sense, it's like I can bubble this out like that. Okay, so let's get to making this guy. So I'll just clear this. Okay, so we're going to start with a polycube and a second polycube. So I have 2 polycubes. The first one is going to be the voxel, and the second one is going to be the volume. And the volume should have a size of about, we could go with something of decent size for a cool effect, like 20 by 20 by 20. And you can even hide that object because we don't need to see it. And then with the first cube called voxel that we named, with it selected, create a mesh network. And in the distribution node, change this to distribution type mesh. And then the input mesh is going to be the volume. Middle click, drag and drop that into the input mesh. And then we are going to choose fill and shell, and the method is going to be voxel. The method is voxel. So here, let's go with 1.1 and really fill it up. So that's a lot of cubes. We've got 6,859 at this scale and size. Now, the first thing I want to do is manipulate the scale of the object and the positions of the object. We've done this before with the last one, except this time, instead of using the mode of offset on the offset node, we're going to use the mode of multiply. And if we choose multiply, we are multiplying by 0, which gives us 0. So we need to multiply by 1. So we're going to enter 1 in all of those fields. So now we're multiplying position, rotation, and scale by a value of 1. So if we scale, say, to 2, and we have an offset position of 2, we're saying push out. Instead of moving in a linear direction, if we were to use offset, it would just move in a linear direction. But multiply, that's special. It's actually blowing it out from its center, which is really cool. Now what we're going to do is create an offset node and, a Falloff object, that will control the offset node. And that fall-off object in this case will be a sphere so that it can have that bubbling effect. And so now when I pass this through, it blows it out in, this is my explosion, my quote-unquote explosion. So it kind of blows it out into these positions, which is really quite cool. Now I can push this a little bit further by, again, using add mode fade. I can use and then as I pass it through, it tends to return back to its shape. Okay, and it's clearly hitting a new silhouette as it blows out into that new size. So what if we could just make it appear a little more random? Also, what if we could push it in? If I invert the fall off, it gives me the effect of pushing it in. Isn't that interesting? So if we just get over here near the corner and maybe increase the scale of this a bit, we have and increase the inner zone a little bit, we have the effect of like pressing. Isn't that interesting? How it presses in to the cube. Now I think that's pretty cool, like an implosion. Explosion, implosion. I should probably rename that, like bubble, implode. These are all just words to describe what's going on. Okay, and then the randomizing. So then over here we've got random, and random is randomizing everything. But again, let's use the falloff node, the falloff object just a little bit differently. So if you select the falloff object, select random, then right click and choose connect. Instead of create, choose connect. We're going to use the same falloff object. So as they move out of position, they're randomizing, and as I press in, it starts taking shape. That's really neat. I like this effect. And I've seen variations of this one, so we could randomize position, really blow it out. We could randomize rotation, just break it up. We can even randomize the scale, so we could go like 0.5, 0.5, 0.5, and even check uniform scale, maybe smaller, 0.1, 0.1, 0.1. And so then we have these like chunks blowing out, which is really, really cool. Going back to the offset, go back into the shape, and then maybe speed up the fade a little bit so it fades a little quicker. Snapping back into position, even inverting the fall off and seeing the effect of seeing how they tear away. And if we change that to normal, it just blows out as we hit it, and they just snap right back to where they were as they exit the fall off area. So that's really cool. I love how as you approach it like a magnet, and it just explodes, tearing in like that. Really, really cool. Okay, next, hopefully in the next 20 minutes, I can do 5, 5A, and 6. So 5 is really easy. We already just saw it. We're going to apply dynamics and drop boxes to the ground, and I'll take a moment to talk a little bit more about dynamics. So this one's already saved. I saved it as mash 4. Let's clear this and make a new one. So again, I want a polycube to start and to mash it. And I want another polycube, and this polycube, like we did before, is going to be the volume. So we can even rename it so that we know that's the volume, and we can hide it. This volume is going to be a 10 by 10 by 10, and the volume is going to be the input mesh for the voxel. There we go. Then with this voxelized, and we'll choose fill and shell. So we've got a volume of cubes, and let's just change that to 1.1, so we have a little bit of a gap between the pieces. Now we're going to apply dynamics. And now if we if we simply hit play, they will fall onto that -20 virtual plane. Let me talk about this virtual plane that they're hitting. That's in this little icon right here, the bullet solver shape. So the bullet solver shape has the collision iterations, which I recommend if you have a stronger computer, you increase the collision iterations. Also increase the internal frame rate if you have a stronger computer. Also, you can decrease the collision margin to something like 0.01. This will help objects to contact each other more accurately. And also notice we have a ground which is at -20, and the ground has a default friction of 0.2, a bounce of 0.2, and a dampening. So we can increase that friction if we want to prevent the objects from sliding around too much. If this is too much, if this object is too much, just go back to the volume, if it's too much for your computer, and reduce this to a 5 by 5 by 5 cube, and it will automatically propagate through, and that should be a much faster calculation. Give yourself more frames to work with. Give yourself 1000. And you can see the objects are sliding around. Now there's two types of friction for this. You just saw the friction in the bullet solver shape, which is here and here. Friction and bounce and dampening. But there's also in the dynamics node the primary place for friction, rolling, and dampening. So the collision shape is the first thing to pick. Choose box. Even though it has automatic is set there, and even though we're using boxes, technically it did use the box collision shape, and the collision shape can be seen here. If we go to visualize collision shape right there, it shows us in red the actual collision shape. If we were to go back to dynamics and choose collision shape of sphere, it would attempt to use the spherical collision shape for each box, and that simply wouldn't be accurate. You can see there's basically a sphere on the inside of each collision box. So we want to choose the correct collision shape type. So now we have boxes. So the red box indicates that. And again, that's in the Again, that's in the bullet solver shape, collision shapes right there. Now, the friction, rolling friction, dampening, and rolling dampening. Friction just basically means don't slide around. Rolling friction means don't roll around too much. Dampening means it's basically what it means. It's going to overall slow everything down, and the same thing with rolling dampening. Basically, it's not the same as friction. It's more like don't roll around as much. So you can see we basically got the pile just falling and kind of sticking to itself. So if we reduce dampening and then rewind and let it play through again when it falls, we can see that dampening has an overall effect on just letting them jostle around. And then rolling dampening has a really big impact on whether or not they roll as they fall. So rolling dampening and rolling friction work very well to stabilize the object. And I usually let the simulation play through as we saw in an earlier example. Okay, and then mass is use mass as density. So mass is a way of indicating how heavy an object is. We don't really get to see the demonstration of this one yet. We'll see a demonstration of this when we get to the brick wall, because when we're going to send like a wrecking ball through a brick wall, and so the wrecking ball has to have a heavier, larger mass and higher density in order to wreck that wall. We're going to see that in another example. The translational velocity is basically a way of saying how much energy does this thing have. Initial translation says which direction are you moving when this thing starts. So I could say it has an initial translation of 20 on the y-axis, and you can see it moves. It tries to like throw itself up, and then it comes crashing down. Or I could say its initial rotation on the x-axis, or even, yeah, like on the x-axis is like say 45. And so it'll spin, and they're spinning out of crazy, and it kind of explodes, and then they come crashing down. And then we could do the same, like 45 on the y-axis, and see it spin and throw off, and an interesting explosion, and that's like its initial hit. So that's something to pay attention to, that when you're using initial rotation and initial translation, and you combine that with initial sleeping, what we're saying is when something comes along and hits it, like we did earlier with bullet physics, its initial translation will be in the direction. We can actually set it to be in the direction of something hitting it and giving it that explosiveness. And then we saw initial state on our last example, and we saw initial sleeping in a bullets example. Translational threshold and rotational threshold is basically how much energy and translation rotation will we need in order to get it going. Right now it's 0. And then we have a lot of interesting constraints. We have per point adjustments, and we have constraints. If we create a per point adjustment and then double click it, we can see that we have a per point construction for per point, what is it called? Per point adjustment for the mass and or the constraints, or whether or not it's active, or how bouncy it is, or its dampening, or its friction, or its initial velocity, and we can set what that starting value is going to be. So, and then whatever the variation of that value is, and its strength, and whether or not there's a fall off on it. Right now, we're not going to look into that any more deeply. If we just right click that and choose break connection. And then constraints, we can look at this one right now. If we create a new constraint, double click it, we have a glue, a spring, a slider, and custom. Slider and custom, you'll have to get to Ian Waters to get better examples of those, but glue and spring I can demonstrate. And we can also look at the bullet solver shape right here and see, yeah, constraints are going to show up in yellow. So now we can see in yellow all the constraints on this glue. Now, if it's not breakable, what we're saying is that they can fly off and they attempt to stay together. And of course, we still have that initial, I'll turn that off, the initial translation rotation. So turning that off, if we just drop onto the ground, we can see that the glue attempts to glue pieces together and keep the chunks together. And if we choose breakable, what we're saying is within a threshold of this much energy, the glue will break. So if we go back to dynamics and we say this thing is heavier, like a mass of 10, and we rewind and hit play, what we're saying is it can break apart as it has more weight as it falls. Turn off the use mass as density for now. And then we have connection mode. Is it touching? Are they nearest? Are they connected point? And so this is, and are they continuously created? So in other words, as this thing simulates, if we turn off continuous creation, it just kind of disconnects them and they're no longer created. But if we have continuous creation turned on and we rewind, we can see that the glue is holding them together. And for some reason, I don't have my constraints turned on. Where did my constraints go? For some reason, the visualization of the constraints went away. I'll come back to that later because we can example this a little bit later. So let's get back to the issue at hand. So dropping the boxes, dynamics applied, That's done. And we had a little bit of a look at what's inside Dynamics. Okay, so now let's do a Dynamics piling up on the boxes, increasing it by duplicating the repo node. Okay, so this is a trick again I used in the Aquablock scene in order to build up a bigger and bigger pile of objects, because the mesh that I was using was very complex and I needed a way to dynamically position them. And I had to use the actual object in order for the collisions to work properly, which meant this was going to be a very expensive calculation. So I came up with a strategy where I would drop many objects and then duplicate the repro mesh. So it looks like this. So by the way, this is number 5. Number 5 is really simple. Okay, now we're getting on to 5A. Okay, I'll need a few more objects to demonstrate this nicely. It's 10 by 10 by 10 on the volume, and rewind and hit play and let it all play out, and then let's just let them slide around a little bit, so a bigger distribution of a pile. So let's do less friction and let them slide around a little bit, maybe an initial translation on the X of 1 just to shift them over a little bit. And then perhaps just an initial rotation just to rotate them and get them to jostle around a little bit better. Maybe a little more. Just trying to get them to pile up on the floor. That's a little better. In fact, I'm going to change this up a little bit. I'm going to have a little bit of fun with this. I'm going to show you something a little different. More than just a pile of boxes. Let's do, let's add a little bit of fun. Let's add a cylinder and a torus and a sphere. Okay, so we're going to add these 3 to the repro mesh. So what we're going to do is come here to the waiter, the repro, and notice we have p-cube1. We're going to take the cylinder, the torus, and the sphere, middle click, drag and drop them into that list. Then we're going to go to our mesh and choose ID. Drag and drop the ID underneath Dynamics. ID is going to be the number of objects, so 4 in this case. And we're going to choose random. Then Dynamics, we're going to choose not automatic, convex hull. And now when we look at convex hull, if we see the collision shape, and if I hit play, they should blow apart. Actually, let's just shrink that down a little bit. So let's change our volume to be a little smaller, maybe 8 by 8 by 8. They'll blow apart. It's calculating a little bit faster. You're going to experience a little bit slower calculation. I am too. There we go. Now we got a nice pile just spreading out. Okay, and they're slipping and sliding around. Stop that. Now let's increase friction and increase rolling friction. Leave dampening alone. Increase friction and rolling friction. Restart it. Play it. You can even hide the original primitives that we added and let them spread out a little bit. Okay, now I'm going to stop it and take a look at it. Look at this. Notice how the torus has a hole in it, right? Well, if dynamics is set to automatic, it will automatically apply the mesh shape to the torus, causing the calculations to really, really slow down. But if you need a very accurate collision, you're going to use the mesh shape. But I'm just going to mitigate that complexity and let this play out a little bit longer. Right up until about here. I'll stop it right here. So here's the idea. This is the new repro mesh, right? Well, do you guys remember this back in modeling? Maybe you don't. I'll tell you right now. This duplicate function duplicates the mesh but wipes away any history. So now we have a repro mesh that we can use as a collision. You see, we can even rename it so that we know what it is. It's the pile. And then we're going to go to the bullet solver shape. By the way, we're solving this is all to solve number 5a. Dynamics, piling boxes onto boxes, or in this case, primitives onto primitives. And increasing it by duplicating the repro node. Okay, so if we then go to the bullet solver shape and set the collider object to be this pile, we can then go into this new, this object now gets a new property. If we double click it, we get a new mesh property where we can do a collision shape of actual mesh. Now that's very expensive. We could probably get away with hull, but I'm going to go with actual mesh. All right, so then I'm going to rewind and deselect. And now the ground plane and that former pile will be a part of this calculation. And so I can pile and pile and pile as high as I need to without having to over calculate collisions by like throwing. I don't have to put in 5,000, 10,000, 20,000 objects. I can just do this basic 1,000 or less and just repeat it on top of it again and again. And visually, it's usually right. And that's lesson 5a. And there it is. And let's turn off the collision shapes so we can enjoy it in its full glory. There's my pile of primitives. I do enjoy a good pile. It's very, very cool. Okay, so that's 5a. Where are we on time? We are actually out of time for this session. This is 50 minutes. So I'm going to pick it up. This is good because MASH number 6 is a little more involved, and it's a good transition for us to get into the serial bowl, which is much more involved. So more dynamics on MASH 6, 7, 8, 9, 10, 11, and 12. So we'll pick it up there. I hope you have a really good day, and I'll see you in the Q&A in the next class.